Hi, my name is Greg Eckert, and I am the SUSE Alliance Lead here at AWS. I'm thrilled to talk to you today about going green with SUSE and Graviton instances. Let's dive in. First, we'll go over AWS and Graviton and show a couple of tools aimed at helping you understand how to manage your current footprint. We'll discuss 9 optimizations that you can make to lower footprint and incidentally, also lower costs. Then we'll get into AWS Graviton instances about halfway through the presentation. What makes them special, what types of workloads they're targeting, which AWS services are compatible, and most importantly, how to choose which instance types are best for your needs. At the macro level, AWS is a founding member of the Climate Pledge, a commitment to carbon net neutrality by 2040 that AWS is taking to the next level. We're investing $2 billion into carbon neutrality, committing to regular reporting, carbon elimination, and credible offsets. 314 other businesses have signed on to the pledge. But when AWS signed on, we set a target of 2030, shaving off 10 years from the climate pledge goal. Andy Jassy, CEO of Amazon, is quoted, "We now have 310 wind and solar projects across 19 countries and are working hard to reach our goal of powering 100% of our businesses on renewable energy by 2025, 5 years ahead of our original 2030 target." At this scale, Amazon is the largest corporate buyer of clean energy. But this isn't a challenge that we can tackle alone, so I'm really excited to also discuss what customers can do to go green. So who's this talk for? Anyone running one of these types of workloads. Open source databases, in-memory caches, microservices, HPC, web and gaming servers. There's a broad range of applications that are covered by Graviton. Let's go into AWS. AWS has the broadest and deepest range of choice for compute. We have families of instances designed for virtually any workload, whether you want to optimize for raw CPU cycles, memory per CPU, even high I/O storage, and powerful GPUs. Each one of these instance families can be further customized, including choice of processor type, type of storage, ultra high-speed networking, or even bare metal options. Add in other options, such as Elastic Block Store, and we have over 475 distinct instance types, giving our customers the most choice and flexibility when it comes to compute. And by the time we leave here, I want to make sure that you know the next steps to identify which one of these 475 types might work best for your workloads. Amazon EC2 also has the broadest choice of processors, including a full range of Intel Xeon processors. And we also leverage the EPYC processors from AMD, powerful but cost-effective options for x86-based workloads. Finally, we have our own custom designed and built silicon, the AWS Graviton family of processors. So what does this have to do with sustainability? AWS Graviton processors are incredibly efficient. But before we get into that, let's discuss the Amazon shared responsibility model. Carbon emissions are driven by 3 items: the number of servers running, the total energy required to power each server, and the carbon intensity of energy sources used to power these servers. Let's talk about carbon intensity of energy sources. AWS infrastructure was found to be 3.6 times more energy efficient than the median surveyed enterprise data center. I've already mentioned the 310 clean energy projects Amazon has in flight to push towards 100% carbon neutrality. Now we'll focus on that last piece, customer optimization. On average, AWS customers use 77% fewer servers, 84% less power, and utilize a 28% cleaner power mix for a total reduction in carbon emissions of 88% from using AWS. In a few slides, we'll get into what you can do to optimize your instances, but first, let's talk about SUSE support. We've discussed the things in green that AWS is responsible for, SUSE supports at the first layer in blue. They primarily help through code efficiency. They have internal measurements, asking questions like, how much more energy efficient is the newest OS version compared to the last version of SLES? When running on SLES, customers can increase efficiency by 8 to 20% by applying SUSE's operating system optimizations. They provide roughly 20 knobs to tune. Two of the big ones are minimizing wait states, making sure that there's no idle CPU, and reducing data usage through efficient cache policies and minimizing data exchange. Every one of these changes are open source. All of these tunable components are open source, meaning that the changes are pushed upstream so that the entire Linux community can use the optimization features. Visit the session catalog to hear more about SUSE's sustainability practices and what they're doing both at the technology level and at the lobbying level in order to push for green technologies. But one commitment that we'll hit more on is their commitment to become an AWS Graviton Ready partner with AWS. The AWS Service Ready program is designed to identify, validate, and promote products built by AWS partners that work with native AWS services. These partners must demonstrate technical proficiency and customer success. From support to performance, SUSE and AWS work together to make sure that your applications can run on Graviton. And now that we've gone over what AWS and SUSE are doing to become green, what can you do to mirror these efforts? The first step is to measure your existing landscape's efficiency. As previously stated, the number of servers running and total energy required to power each of those servers are two of the three major components to understanding your carbon footprint. And you can't fix what you don't measure. And this is why AWS recently released the AWS Customer Carbon Footprint Tool, which you can use to understand how much EC2, S3, and other emissions that your company is producing, as well as review emission savings by virtue of running on AWS. Underneath, but not shown in the screen here, so if you go to the website, you'll see it on the bottom. You can also see AWS's progress towards our commitment to becoming emissions neutral. Next, we have Amazon CloudWatch. Energy proportional computing, a new definition, reported that compute resources should be maximized on average 70 to 80%. This is because energy efficiency quickly decreases as performance drops. You can see how optimized your resources are by using AWS CloudWatch. And CloudWatch can help you monitor things like CPU utilization of EC2, total number of vCPUs, or Amazon ECS via CPU utilization. In addition to CloudWatch, AWS has Cost and Usage Report, where you can understand resource usage. And once you understand your use, there's a lot that you can do. Before we move forward with this slide, I want to make a recommendation that you take a screenshot because we won't be coming back to many of these items. Here are the 9 ways customers can become more energy efficient. For the rest of this talk, we'll be discussing one of these advanced topics, modernizing your resources. But before we move on, please do the beginner topics. Stop paying for underutilized storage and networking and even compute. Fine-tune Redshift if you're running it, and enable S3 intelligent tiering if you're using S3. We're building a house here, and you want to make sure that your foundation is right by doing the easy items first. And once these items are complete, it will be time to modernize your resources. One way to do this is to deploy on Graviton instances. We've built the Graviton chip to run optimally on AWS with targeted optimizations for specific cloud-native workloads. As discussed earlier, one of the 3 pillars to energy efficiency is the total energy required to power each server. So let's talk about the chip. Let's look into what makes each Graviton2 instance. First, we have the Graviton2 processor itself, which is 7 nanometer custom silicon and offers just exceptional performance. However, Graviton3 is not the first or only piece of custom silicon powering Amazon EC2. The Nitro security chip is integrated into the motherboard of each server and protects and monitors hardware resources. The Nitro card itself unloads many of the traditional software needs of the hypervisor into bespoke hardware, allowing for much better performance with a much lighter footprint. The Nitro card handles interfacing with devices such as Amazon EBS or Amazon ENA, and also provides additional monitoring and security for these instances. Finally, because of the Nitro security chip and Nitro card, the Nitro hypervisor itself is much more lightweight, handling memory and CPU allocation with bare metal-like performance. These purpose-built and modular building blocks give Graviton2 based instances tremendous performance and efficiency. But how does this translate to customers? We have accelerated performance in multiple application categories, from high-performance computing to media encoding, in-memory caches, and even the EDA we ourselves use to design the processors. We continue to innovate, launching support for additional workloads as we optimize our chips for your workloads. AWS has a number of instance families covering various use cases. With AWS Graviton3, our goal is to push the price performance envelope for a wide variety of customer workloads in Amazon EC2. With the new IM4GN, IS4GEN, and G5G instances, we now have 12 EC2 instances powered by AWS Graviton2 processors. These are available across 23 AWS regions around the globe. These instances provide the best performance in Amazon EC2 for general purpose, compute-intensive, memory-intensive, storage-intensive, as well as GPU-based workloads. The new IM4GN and IS4GEN instances also feature AWS Nitro SSDs that are custom designed by AWS to provide high I/O performance, low latency, and minimal latency variability for storage-intensive workloads. IM4GEN instances provide the best price performance, while the IS4GEN instances provide the lowest cost per terabyte of SSD storage for storage-intensive applications. The new G5G instances are the first ARM-based instances in a major cloud to feature GPU acceleration. They feature AWS Graviton2 processors and the NVIDIA T4G Tensor Core GPUs, and provide the most cost-effective GPU-based platform in Amazon EC2 for graphics applications and machine learning inference. Android game developers in particular can use these instances to build their games natively on ARM rather than cross-compiling or emulating x86-based instances. We now have thousands of customers who have realized significant price performance benefits with Amazon Graviton2 based instances. And in May, we were excited to announce the latest generation of Graviton3 processors, which provide up to 25% better compute performance than AWS Graviton2 processors. We're introducing Amazon EC2 C7G instances powered by AWS Graviton3 processors that will provide the best price performance for compute-intensive workloads such as HPC, gaming, video encoding, and CPU-based machine learning inference. These instances provide up to 25% better performance compared to 6th generation Graviton2-based C6G instances. The C7G instances are now generally available. To help customers reduce their carbon footprint, AWS Graviton3 processors, just like Graviton2, are more energy efficient, up to 60%. Instead of going through the rest of the instances specifically, I'm going to point you towards a resource. But quickly, SpecInt is a computer benchmark specification for CPU integer processing power. Unsurprisingly at this point, you'll see that they found higher performance per watt and lower carbon footprint on Graviton processors than comparable non-Graviton instances. So how can you tell which instances you should try out? This is another point in the presentation where I recommend that you take a screenshot or copy down the link, or if you have a really good memory, remember to search this later. I'll also have the link at the very end of my presentation so you can copy it down. On this web page, you'll notice all instances are categorized by general purpose, compute optimized, memory optimized, etc. And broadly, within each category, you'll notice one of 4 benefits: best price performance, memory, compute, network storage optimized; cost savings, lowest cost per gigabyte of memory; and lowest cost per terabyte of SSD storage. Availability is also listed on this page. So after this presentation, as a next step, head over to this page and identify and prioritize which specific Graviton instances will work best for your particular applications and optimization requirements. Now that you know how to identify which processor to use, let's see what customers are saying. Honeycomb shifted the majority of their workloads to Graviton3, achieving a 35% reduction in EC2 instances compared to their previous instance family. When this quote was created, they were running some tests, and a year out from running the initial experiments, they report that 92% of vCPUs in use by Honeycomb are running on ARM instances. But they're not the only one. Other customers have shared their excitement, from Twitter reducing latencies by 35% using Graviton2, to Formula One discovering that Graviton3 instances are 40% faster than the comparable Graviton2 instances in their simulations. As Epic Games is quoted, they are suitable for even the most demanding latency-sensitive workloads while providing significant price performance benefits. And in addition to Amazon EC2, we have also extended the benefits of Graviton2 to managed AWS services, including Amazon Aurora, RDS, DocumentDB, Elasticache, and many more. Customers using Graviton2 instances in these managed services have experienced significant price performance benefits with little to no code changes. At reInvent, we also launched Amazon FSx for Lustre and Amazon FSx for OpenZFS, which are fully managed services for cost-effective, high-performance, and scalable storage. Both of these are powered by AWS Graviton2 and deliver price performance benefits to customers with fully managed storage, with a fully managed storage experience, rather. In addition to managed services, many major AWS infrastructure services, such as Amazon EKS and ECS, also support Graviton2-based instances to help customers orchestrate, monitor, and secure their instances. So to recap, Graviton2 powered instances can lower the total cost of ownership significantly. The AWS Graviton2 powered instances have the highest performance within their instance families, along with 20% lower costs when compared to other instances in the same vCPU and memory configuration. This leads to up to a 40% better price performance versus comparable x86-based instances, and up to 60% energy efficiency over comparable non-Graviton EC2 instances. I welcome you to visit aws.amazon.com/ec2/Graviton, or email me at gregecke@amazon.com if you'd like any more details. Thank you, and don't forget to visit the other AWS sessions throughout the show.